Okay, we are discussing the stochastic approach for the traffic arrival, and we said in a stochastic approach we are not interested in numbers, we are interested in the chance or probability of the numbers. Okay, so we said the data follows Poisson distribution. The Poisson distribution has an equation for calculating the probability, which you can see on the board. And in this equation there was mu, so we replaced mu with lambda, and then we said that we can make this equation in terms of headway as well, okay, by putting x equals to 0. Okay, so if the time is less, headway is more, your x will be 0, and the equation can be in terms of headway or for the chances of headway. Last time we saw some examples, okay, for the Poisson distribution. Okay, so this one was very simple. You have to calculate the probability for each number, and then only for the last one, okay, since we already have from 0 to 4, then for the last one, which was 5 and above, we did 1 minus all the other probabilities. We will get the probability for 5 and more. In this example, I think there was what? Yeah, this was for the headway. Okay, so instead of using the equation, the general equation, we use the equation which was for the headway, to have headway less than or equal to 8 or more than 10 and the probability between them. This one was again the probability for number of cars, number of arrivals. Okay, so the number of arrivals we are looking for was 6 or more. So again we will calculate the probability for 0 and 1 and 2 and 3 and 4 and 5, and then 1 minus everything will give you 6 or more. But they were saying give us a probability that consecutive 3 minutes will have this probability. Okay, so you will multiply the probability of 1 minute up to the power 3 because they are asking for 3 minutes. Okay, if they say probability that the first minute has 6 and the second minute has 3, then you will find out the probability of 6, find out the probability of 3 and multiply them. Okay, so basically we are trying to multiply the probabilities, but obviously if the probability is same, if they are asking for the same number, you will take the power. Clear? Okay. And this one was to find out how many gaps you have, acceptable gaps. Okay, so your headway becomes the acceptable gap, and then t is the time, obviously. So to find out the gaps, then we multiply with v minus 1, where v is the flow on the main highway. Okay, so if the flow on the main highway is v, then you will have v minus 1 gaps in traffic. Okay, so what is the probability that these v minus 1 gaps will be more or equal to the headway, or sorry, less or equal to the headway you require? This is this probability. Okay, and so on and so forth. Then we looked at one example as well, and then we had the concept of minimum headway. So headway is the time interval between two vehicles. Okay, so this cannot be 0, and according to the acceptability of the driver, it may not be 1 as well. Okay, drivers will not be so close that you have only 1 second between them. So they are the minimum acceptable headway for the drivers. Okay, so the probability should not include any value of 0 or any value of 1 or any value which is below the acceptable headway for the drivers. Okay, so you should subtract that from t, so you will get the remaining. Okay, clear? Just a small clarification which I did not make earlier. There is one thing which is called as acceptable headway. There is another thing which is called as acceptable gap. Acceptable headway, acceptable gap. What is the difference between them? I told you earlier headway is gap. What is the difference between acceptable headway and acceptable gap? Yeah, the acceptable gap is that headway in the main stream which the driver on the minor stream will accept. So it is from his acceptable for the minor stream headway which will be acceptable for the minor stream to enter. An acceptable headway is simple headway which you will accept between you and the other car. So it's the same stream. Two drivers in the same stream, they maintain some minimum headway, that is acceptable headway for them. Okay, but if you are looking at it from the minor side, that is acceptable gap. Clear? Okay. So headway is between two cars, but if you are looking at the headway from the minor side, it becomes gap. Okay. Now we will move on to queuing theory. It's part of the same topic. Okay, and we will continue with the stochastic analysis. Okay, and deterministic analysis. I have taken it from this book. Okay, so this book is available on the internet as well. I think they have a new edition as well. But there's nothing, no change here. Okay. So we have discussed earlier. Why is Mr. Ram? You don't like him?
What about him?
Huh? He saw you coming, you put the seat back. So you don't sit here near him.
I didn't see him, Victor.
He comes, the whole corridor knows he's coming. Done?
Okay.
Okay. So we have talked about queues earlier as well, right? So why it is important? Because queues can form anywhere. It can happen on an expressway, on a ramp, on an intersection, signalized, unsignalized. It can happen on any type of road. Okay. So they are a result of congestion. Whenever there is congestion, traffic jam, then we can have queues, and then we have delays as well. We have pollution, we have noise pollution, and so on and so forth. Okay, so they can affect, or they do affect, a lot of people in any situation. They can happen on any type of segment. So queuing theory is about what? Queuing theory is the mathematical algorithms or approaches that deal with the process of formation of queue. Okay, so the equations which deal with the formation of the queue. Okay, that is called as queuing theory. Maybe I said it earlier as well. Whenever we say the word theory, theory is proposed to do what? What is the purpose of having a theory?
So that we can follow it.
Huh?
We can follow it for different
Different
cases.
different like cases. Okay, so yes, theory is to explain a phenomena. Okay, to explain something which is happening, then we have a theory. So when you follow the theory, then you can see what is happening and why it is happening in this way. Okay, so queuing theory explains why the queues happen and what trend they will follow. Okay, so its applications involve all types of segments and highways. Yeah, we need to consider three factors for queuing theory. For queuing analysis, we need to consider three factors. Okay, the rate of arrival. Okay, is it uniform or Poisson distributed? Okay, the rate of arrival, is it uniform or it is following some probability? Okay, what is the other name we gave it? Stochastic. Okay, Poisson distribution means, is it stochastic, or uniform means is it deterministic? Okay, then how many channels we have? Okay, channels meaning each channel is serving the demand. Okay, each channel is serving the demand. So how many channels means how many points there are which are serving the demand. Okay, so for example, you go to Causeway, let's say. Okay, or you go to the airport, so they have counters, right? So each counter is a channel. You have 4 channels open, 4 counters are open. That means this demand can be served through these 4 points. Okay, in terms of highway, you can say number of lanes. Okay, So we have 4 lanes. So demand can go from these 4 lanes, right? So the number of lanes will become the channels. Clear? If you have 3 doors to a building, 3 gates to a building, okay? So these 3 doors are 3 channels. The demand can be passed through 3 doors, 3 channels. Clear? Okay? You get the meaning of channels. The point which is serving the demand. Okay? Then we have the queue discipline. Okay? Queue discipline means they are how they are leaving the queue. So we have the LIFO approach and the FIFO approach. Okay? You guys have taken economics, right? Remind him, yes, we have taken. That's why you are here. Okay. So, anybody remembers this? Nobody, right? Huh?
It's one best.
LIFO means last in, first out. FIFO means first in, first out. Okay? Last in, first out. And first in, first out. Okay? So last in, first out, you come late, go early. Now you understand. See?
What about FIFO?
First in, first out.
Like me.
Last one to come. Huh? These two maybe. What? Never out. Okay, so you get the point, huh? Now, if you have a queue of vehicles, which approach is followed? Okay, let me make it easier. Which approach is followed normally? Normal.
LIFO.
Huh?
No. FIFO.
See?
No, LIFO. It's called LIFO.
Which one is normal? FIFO, right?
FIFO there.
First in. Okay, so the queue is moving. You are at the top, you are at the front, and you leave, right? So if you are the last one in the queue, then you reach the front and you go, right? This is normal. This is normal. Okay? But obviously,
FIFO.
they are
Maybe sometime LIFO.
sometimes FIFO, right? So you come and go like this. If you have a big car, then go from the shoulder, go from the median, go from somebody's house. Okay, it happens, right? But the normal one is FIFO, okay? So, but LIFO can also be applied somewhere, okay? So in general, queuing theory, you have to consider 3 things. How people are coming. Are they coming uniformly, or they follow some probability distribution, Poisson distribution? How many channels you have to serve them, and what approach you have for their leaving of the queue, okay? For traffic, we will say FIFO, but there can be many other applications of queuing theory in which other approaches are also applicable. Okay, so we will start with deterministic analysis. Okay, deterministic analysis means what? Uniform, right? So every situation has one value. That's it. If you tell me number of vehicles at this time, how many? I will give you one value. And that value has a chance of how much? 100%. Okay. Then in deterministic analysis, we have DD1 case. Okay. So there are different cases in deterministic analysis. Okay. But the concept is same. In all these cases, we are considering that there is only one value which has full chance. Okay. What does DD1 means? The first D means deterministic arrival. So arrival is deterministic. Okay. The second D means the service rate is also deterministic. Service rate or the departure rate. Okay. So they are arriving uniformly. They are going uniform. Okay. And 1 means number of channels. So you have only one point of serving of the demand. Okay. So DD1 means arrival is deterministic, departure is deterministic, and from only one point, one lane. one lane, one gate, whatever you assume. Okay, one channel. Clear? Okay. In this case, we can have 4 conditions. Okay, so we are talking about deterministic analysis, DD1 case, and within DD1 case we can have 4 scenarios, 4 conditions. Service rate is varying and demand is constant. We have 2 things, right? Arrival, departure, right? Arrival, departure. Okay. The first case is arrival is constant, departure is varying. Okay. So arrival is, let's say, arrival is 100 vehicles per hour. That's it. It doesn't change. So arrival is 100 vehicles per hour, doesn't change, whether it's the first hour or the last hour. Constant. Service rate or departure rate, in the first hour it was 100, second hour it's 200. Got it? Okay, the first case. Second case is demand is varying and the service rate is constant. Okay, so demand in the first hour is, let's say, 100, second hour it is 200, third hour something else. But the service rate or the departure rate, constant. Whether it's the first hour, second hour, third hour is same. Okay. Then we have the third case, both of them are constant. And then we have the last case where both of them are varying. Clear? Okay. So we have the first D and the second D. First D, you can have both of them constant, both of them varying, only the first one varying, only the second one varying. Clear? Clear? Okay. Now what type of analysis we are doing? Deterministic, right? So why are they varying there? Deterministic, I told you what? Only one value, right? So how is it one value and varying?
Varying for many hours.
Yeah.
So it's one value an hour.
Yes, yes, yes. Okay, very good. How did you say this?
Because I was studying the
Hmm? No, you took economics. Okay. So every hour it's varying. So with respect to time it is varying. But if you fix the time, the value is fixed. Okay. So varying means with respect to time it is varying. Okay. But in a particular time there is only one value possible. Okay. Clear? Now I will tell you the case like we have discussed the case now. Okay. DD1, and there are some examples. Okay. There are some examples in the case. Okay, we will try to see how to work with the examples. Okay, so there is no like I will give you an equation and every question you will follow the same equation. It's not like this. Okay, so try to focus on the approach. Okay, the values can change, the equation can also change. The equation can also change. Okay, so vehicles arrive at an entrance to a park. There is a single gate. This is what now? One what?
One channel.
Channel. Okay. And all vehicles have to stop at the gate. They will give them a useless brochure. Okay. And then they will enter. Useless because they are already going inside. Like, why do you need the brochure? Now we are going inside. No, stop. Take this. Huh? Okay. The park opens at 8 a.m. and people start to come at 8 a.m. and everybody for some reason like they want to come in the morning at 8 a.m. See? People are not coming at 12 p.m. These are ready to come at 8 a.m. See?
They have set up.
What? No, these are just going for visiting the park. Okay? So at 8 a.m. they start at a rate of 480 vehicles per hour. After 20 minutes, they get into their senses, they become normal. Then they start to come at 120 vehicles per hour. Okay? It continues at that level for the rest of the day. Okay? So whatever the rest of the day means, it continues at that level. The time required to distribute the brochure is 15 seconds. Okay? So to give the brochure, they stop the vehicle for 15 seconds. Got it? Assuming DD1 queuing, okay. So arrival is deterministic, service rate is deterministic, and there's only one channel, as they already said. Describe the operational characteristics of the queue. Okay. Operational characteristics means what? Arrival rate, departure rate, okay. Number of vehicles, equation or value for number of vehicles which come at any time. Okay, equation or value for number of vehicles which come at any time. Okay, and equation or number of vehicles which go at any time. And the last one is we plot the arrivals and departures. I will show it to you. From the plot, we can find out something else as well, some other things as well. Okay, because they are just saying in general, find out the operational characteristics of the queue. What are the operational characteristics of the queue? Arrival rate, departure rate, number of vehicles arrive according to time, number of vehicles depart according to time. Okay, and then we have the plot as well. From the plot, we will look at a couple of more things. They are all part of operational characteristics. Clear? Clear? Okay. Now, the vehicles arrive at 480 vehicles per hour, okay, in the first 20 minutes. Okay, so that's why we have the division here. Whatever is happening in the first 20 minutes is different than what will happen afterward. Okay, so first 20 minutes they are arriving at 480 per hour, where T is in minutes. Yeah, T is in minutes. Okay. So what will be the equation? Tell me. If T is in minutes, in the first 20 minutes, let's say arrival rate equals to what? Tell me. No, it's vehicles per hour and it's fixed number, right? I want an equation in terms of time. First of all, what is your time? What are the units?
About, we have to convert it to
Minutes, right? Okay, so 480, first thing you will do is 480 divided by 60. Okay, so this will be what?
Right.
Per minute, right?
Yeah.
Rate per minute. Okay, so this is how much now? This is how much? Huh? 8 per minute? Okay. Okay. Now, arrival rate after 20. What is that? Huh? So it was 120 per hour. Again, divided by 60, it becomes 2 per minute. Clear? Any problem? Clear? Okay. Next one is what? Departure rate per minute. Now departure is how many? How many vehicles? Each vehicle takes how much? So how many per minute? 4 per minute, right? Okay. Clear? Every vehicle takes, one vehicle takes 15 minutes or 15 seconds. So in 1 minute you can have 4 vehicles, right? Sure. Yes. Clear? Okay. Then number of vehicles arrive during time T when T is less than equal to 20 or more than 20. Okay, so this is now number of vehicles. You already have the rate, right?
Yes.
You already have the rate.
The right time.
Okay. So I'll call it NA. Okay, so 8 into
T.
T. Okay, this will
Maybe for 20.
okay. and it will change to
4 times 2 times
2 times t and what else? Remember, we are calculating to number of vehicles. So it's 2t, yes, because the rate is 2 per minute multiplied by t. But you have to add something.
minus.
You have to add something. What you will add? This starts when?
After 20 minutes.
After 20 minutes. So the number of vehicles which are in 20 minutes should be
160.
added, right?
160.
They should be added. They are already there, right? They start to happen after 20 minutes. In the first 20 minutes, you have 8 into 20, which is how much? 160. Okay, so this will work when t is more than 20. Clear? So somebody wants to calculate number of vehicles after 30 minutes, he will directly use the second equation. That's it. Okay? If you don't add 160, then he has to use the first one, then take the number, then okay, and so on and so forth. Okay, clear? Any problem? Okay. Number of vehicles departed during time t. This is very easy. Vehicles departed, because it's a constant rate. So I already know the rate, which is 4. So multiply by t. It doesn't change. Okay, so it's the same. Clear? Okay. Now the next one is the plot, right? So for the plot, you start from 0. Start putting the values from 0 in this equation and this equation. For the plot, we need x and y, right? We need x and y. So you start putting the values from 0. Start from 0. Then you can put 0, 5, 10, 15, up to 20. You can use this equation. Okay. And then you will start using this one. After 20, 25, 30, 35, so on, you will use this equation. But this is only for arrivals. For arrivals. For departure, this one. Whether it is 0 or 5 or 10 or 35 or 500, whatever. Clear? Okay. So the plot is here. This is the plot. So they did it after every 10 minutes. They did it after every 10 minutes. So you have time on the x-axis, t value, small t, and you have number of vehicles coming on the y-axis. Okay. So this one is for the departure. The departure rate was constant, right? Departure rate was constant, 4 per minute. So you can see a straight line. It doesn't change. Okay? Clear? Sure? Okay? So it was 4 into t. So every time you have t until you have 4, you will get the value. Okay? Clear? For this line, you can see it changes where? 20. Because after 20, the equation is different. Okay, so you can see the change here as well. Clear? Okay. Once you plot it, and then you plot both the lines, you can find out different things from the graph. Whatever.
شكلنا نمشي نخلص هذا. هذا شوي.